Okay, for this question, it says the transformations given are performed on pentagon ABCDE to create a new pentagon. So we have two transformations happening. We need to know what these transformations are. This is a translation, and then clockwise rotation, 37 degrees about the origin. Complete the sentence to explain whether or not the pentagons are congruent. So we talked a lot about this in earlier questions. The transformations that keep the shapes congruent are translations, rotations, and reflections. So if these two, translations and rotations, are applied, the pentagons will still be congruent. We didn't change the size. So pentagons A, B, C, D, E, and the prime pentagon are congruent because each transformation preserves side length and angle measurement. Okay, remember that dilation is the one that would change the size. So dilation would not preserve side length. Okay, it would keep angle measurements, but it would not preserve side length. Okay, number 41. We have a picture here of a couple triangles. It says segment KG bisects angle FKJ. So FKJ is this angle, and if KG bisects it, that word bisects means cuts in half. So we're going to say these two little angles are the same size. Angles GFK, GFK, and JHK, JHK are congruent, and those are marked on our picture. And then we have line segments FK and HK are marked. We have a proof that goes with this picture, and two lines are filled in as givens because those are the things that they told us. And then it says definition of angle bisector here. Okay, I don't really care for this problem, what goes in step 3, because my problem says what could reason 4 be. But if it was switched around and I had to do line 3, if I have definition of angle bisector here, then I would have to have two angles that are congruent here. So remember, this was our bisector. So we would have to say angle FKG is congruent. That's this little angle here to this little angle. So we could say HKJ. Right, so now we go on to the triangles. When you have the triangle congruent to another triangle, you have 5 choices. Our 5 congruency methods are these options. Anytime you see triangle congruent to triangle, you know you're going to pick one of these. Okay, so I can see from down here, all of these choices are valid choices according to my list of possibilities. So now I just have to decide which one is this set of triangles. So I mark my triangles with A's for the angles. So A's for those, A's for these blue angles, and I'm going to mark an S for the sides. If I focus on one triangle at a time, so just focusing on that triangle, okay, I'm not looking at the other one, I can see it goes ASA, the sides between the two angles that are marked. And then if I focus on this triangle, I can see ASA, the side is between the two angles that are marked. So this is going to be angle side angle, which is choice D. Okay. Number 42, we're looking at some properties. It says if a polygon is a quadrilateral, okay, quadrilateral just means 4 sides, then 2 pairs of opposite sides are congruent. Which polygon is a counter example? So that means which one proves it wrong. Okay, so I'm looking for a polygon that does not have 2 pairs of opposite sides that are congruent. So opposite sides are congruent, that's 1 pair. opposite sides are congruent. That's 2 pairs. That is not a counterexample. In this picture, opposite sides are congruent, and these opposite sides are congruent. So that's 2, so not a counterexample. Down here, these opposite sides are congruent, and these opposite sides are congruent. So that's 2 pairs. In this picture, these are opposite sides. They are not marked the same. These are opposite sides. They are not marked the same. We don't have any opposite sides that are congruent. This would be our counterexample because it proves this wrong. Okay. Number 43. We have a sequence of transformations maps QRS onto triangle XYZ. Select all the sequences of transformations that could have mapped triangle QRS onto triangle XYZ. If you are mapping a triangle onto another triangle, that means it fits on top of it perfectly. So it has to be congruent. Remember, we talked about what makes a transformation be congruent. We could have a translation, a reflection, or a rotation. We do not want a dilation. So as I go through my choices, I see a reflection, okay, I see a reflection and a rotation. Those are both okay. I see so I'm going to pick A. I see a rotation and a reflection. Those are both okay. So I'm going to pick B. I see a dilation. I'm not even going to read the rest of it. I know that's wrong. I see a reflection. That's okay. Followed by dilation. That's wrong. I see a translation. That's okay. And a rotation. So this one is correct. So we have 3 that work. Remember, it's select all. As soon as you see select all, you know you need at least 2. Sometimes it's more than 2. This is an example of when we had 3 that were correct. Okay, it's really important to read all of your choices for select all. All right, number 44. We have triangle ABC on our grid here, and it goes with these problems over here. It says complete the steps to describe a sequence of transformations that will map the triangle ABC onto itself. So that means I'm going to move this somewhere, but then I'm going to move it back onto the same spot I started with. So it says step 1, I move ABC up 4 units. So if I move them up 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, I'm up here. If I have to translate this again, it's saying how many units down would I go? Well, if I'm trying to map this onto itself, I have to undo what I just did. So I'm going to have to move it back. Oops, sorry about that. I'm going to have to move it back 4 units down because that will put it back to the original spots. And then it says dilate the triangle by a scale factor of, and then it says centered at the origin. So if I'm going to dilate a triangle and I want it to still be the same size, I don't want it to change at all. Okay? Remember we said that if our scale factor is between 0 and 1, it's a reduction. And if we said k is bigger than 1, it's an enlargement. So the only number I could use in this situation to keep it exactly the same is 1. I don't want to change the size. I want it to fit exactly on top of where I started with. So I'm just going to leave my scale factor at 1. That does not change the size. Okay, then we have one last question on here. Complete the statement to describe triangle ABC. So we have these midpoints because I can tell they're the middle by these congruency marks that are connected to the vertex. That means these are medians. Okay, of triangle ABC, meet at point. Well, where do my medians? This is a median, this is a median, this is a median. Where do they all meet? They meet at O. So medians, and they meet at O. Now, most likely, I really doubt your question would be this easy on the test. It probably would have to say what O is. O is called the centroid. Okay, where all the medians meet is called the centroid. If you don't remember these vocabulary words, I would take a minute to study them. The perpendicular bisectors meet at the circumcenter. The angle bisectors meet at the incenter. And the medians meet at the centroid. I don't think you're going to have to do anything with altitudes, but just in case, the altitudes meet at the orthocenter. Okay, that's just the vocabulary that you might need to know in case you had a vocabulary word to pick from.